Everyone. Today we are going to see about the same semiconductor large gate problems. The last part of this one, we are going to see some of the important problems which was asked in last previous year questions, all previous year question papers. We are going to see about some of the important problems which is solved last year. Last year questions or even a previous year questions which was asked in entrance examinations that we are going to see. So, the first questions here is what will be the input of A and B of Boolean expressions. They have given the Boolean expressions. These questions already they have asked in the previous questions, previous year entrance examination. See in this expression there are two methods we can follow. One is simplifying this equation. Another one is directly substituting the answer. Which one you feel better? You can write on this one. I will show you in the both way. The first one, see here. First one I just substitute the value in this case. The first one I just mentioned here. First one here is A plus B. I just mentioned this one. A plus B whole bar dot this one A dot B whole bar. So if you substitute whether it is 0, 0, 0, 1, 1, 0 or 1, 1 in 4 of this value, you have to substitute directly towards this and have to find out the answer which should be equal to 1. First one I just mentioned 0, 0 only. A equal to 0 and B also 0 here. See I just mentioned here 0 plus 0 bar dot again this one here is 0 dot 0 bar. So what will be the answer? We are going to find out it should be equal to 1. See I just mentioned here. See for this one I just mentioned in this case 0 plus 0 is 0, 0 bar dot again 0 dot 0 also 0, 0 bar. So from this one what you are having 0 bar is 1 and 0 bar is 1. So from here answer here is will be equal to 1. So we can confirm that one this is the answer. For example, I just substitute the second value also here. See for this one A equal to 0, B equal to 1. So 0 plus 1 whole bar here. So this is about the second options, right? And dot 0 dot 1 whole bar here. See for this one 0 plus 1 is 1, 1 bar here dot 0 dot 1 is 0, 0 bar here. So what you are going to have here is 1 bar here is 0, 0 bar here is 1. So what you are going to have here is 0. So this is not equal to 1. So second answer won't be there. So similarly like this all the answer you just substitute here. This is the one way we can confirm 0 comma 0 is the answer, right? The second way I just mentioned here. Second way here is say this one A plus B whole bar and here is A dot B whole bar here. See, we are going to simplify this one. A plus B. See here, A plus B. If you are going to substitute the bar here is this one A bar plus will become dot here B bar. Next one, again this one here is A bar. See, bar is not substitute here. Only see bar is not given to. See, bar is only for these two terms and these two terms, not on this one. So you are going to substitute here is dot only. See, in this case, I just mentioned as dot only here. And next one here is A dot will become plus B bar here. Now, see, even you can multiply and simplify this one, or else you just substitute the answer A equal to 0, B also 0 here, bar bar. Next one again similar here is A equal to 0 bar plus 0 bar. You just substitute the values and get answer 0 dot 0. 0 bar is 1, 1 dot 0 bar is again 1. See, next one we just multiply over here. This one is 0 bar is 1, 1 plus 1. 1 plus 1 is again 1 here. 1 dot 1 is 1, 1 and this one answer also here is 1. See, both the case 1 dot 1 is 1. So answer in this case 0, 0. Okay, next one here is the given figure shows the waveforms for input A and B that for the output Y of a logic circuit. So the logic circuit, what type of the logic circuit is? See, this is quite interesting and even you can easily find out there are some shortcuts I will tell you to understand better and you have to finish it soon very fast. So similar like that I just tell you which way you have to follow. The first one already I told here in the previous problems I have shown in this case, previous part sessions I have showed this one. See, for there are four inputs T1, T2, T3 and T4 here. You always find out, see, we have to mention what is that input value, what is that output value. See, for input value here is the first input, this is zero form. If the waveform which is at the lower amplitude is 0, higher amplitude you just mention as 1. 0 means off, 1 means on. That's all, simple concept. See, for the first one, T1 here is 0. T2 we always go through on ending point. T2 here is on, that is 1. T3 here is 1 and T4, see here ending point is just 1. T4 is 0. See, first one I just mentioned here, 0, 1, 1 and here is 0. Am I clear? Says this one is 0 and this one here is 1, 1 and here is again this is 0. Similar one. See here for B here is this one. Initial point is this one. Final point is here 1. Again here is 0, 0. Again see here in this case 1 and here is 0. And the third point you just concentrate here. This is 1 again and this is 0 here. And output I just mentioned here 0, 0, 1, 0. So according to this we have to follow. See, to understand this one, what I'm going to do here is I just make a truth table for each waveform. For the first waveform I just mentioned here, this is A. What are the input of A? What are the input of B? And what are the output Y? Now, first one, in the first case, see here, according to this, I just tell you, see for the first input here is T1. T1 here is 0. T2 here is ending point we have to see, that is 1. T3 here is 1 and T4 here is ending point is this one 0. So according to this I just mentioned here, for A input first one here is 0 here and second input here is T2, that is 1. Third input again 1. Fourth input here is 0. Similar like this for the B waveform. See here, first one is 1, second one is 0, third one is 1, fourth one is 0. See, first here is ending point 1 now, and the second ending point 0, third ending point 1, fourth ending point here is again 0. See, accordingly, I just mentioned here, first one is, what is that value? First one is 1, second one is 0, third one is again 1, fourth one is 0. Similarly, for the output waveform I just mentioned here, output here is for T1, Y, third one, see here, Y waveform, third one here is 0, fourth one again, T2. T2 here is 0 and T3 here is 1 and T4 here is 0. Now, see first you just go through on AND table. See here, AND gate you just go through on AND gate. AND gate formula already you know this one. AND gate formula here is I just mentioned as A dot B and OR gate here is A plus B and NAND gate means AND gate, see A dot B whole bar. That's all. That is AND gate plus NOT gate. See what you mean by NAND gate? AND gate plus NOT gate. So I just mentioned here NOT gate. AND gate plus NOT gate here is NAND gate, and NOT gate here is A bar simply. NOR gate here is only one input, one output. So this option won't be there. So from these three, first I just use this one A dot B. First here I just mentioned here, for in case of if it is A dot B means 0.1 now, that is 0, 1.0, 0, 1.1, 1 and 0.0, 0. So answer here is this one only. We just confirm about OR gate also I just mentioned here. OR gate here is A plus B. See A plus B, see for this one again I just mentioned here. So this one again I just mentioned in this case, that is OR gate function. OR gate function here is A plus B, that is see here OR gate function I just mentioned little fast, 0 plus 1, 1 plus 0, like that only I have to mention here. I just write on in this case 0 plus 1 here is 1, 1 plus 0 also 1 here, 1 plus 1 is 1, 0 plus 0 here is 0. So in this case, OR gate will not be there. And third one is about NAND gate. NAND gate, I just put a complement of this answer I just mentioned here. That is NAND gate. This is AND gate here. AND gate plus complement, you are going to have a NAND gate. See this one 1, 1, and this is 0 here, and this is 1. So from this one, these two answer is not there, only on this answer. So from this one, answer in this case here is an AND gate. Here is the minimum number of gates required to realize this expression. See what they have asked here is they have given one expression. From this one, how many number of gates are required, how many number of gates in that case, logic gates, AND gate, OR gate, NOR gate, in that gates any one we have to mention in this case. See for that, you have to simplify this equation. For this one, first let me tell you here. First one, see I just mentioned here in this case, the first one I just going to simplify this equation I just mentioned here. See for in this case z equal to, see from this one, what are the common terms, I just take it out, that is dA. So remaining one here is, the remaining value here is BC is there, and here is BC bar is there. Now, from this one, according to this one, what is that value of BC plus BC bar here is 1. So how I'm mentioning this one here is 1. For example, if you mention BC, for example, BC I just mention as, you just consider X for example. And BC dash you just mention as X bar. See from this one, X plus X bar will be equal to 1. Or even the same De Morgan's theorem they have given as A plus A bar will be equal to 1. That means how you can understand this one, De Morgan's theorem, already I told this one. If you want to understand De Morgan's theorem, you always substitute the value either 0 or 1. See for example, if I substitute here 0 or 1, I just going to substitute. Instead of A, I just mention as 0, and here A bar here is 0 bar, 0 bar here is 1. So what you are getting, that answer here is 1. Now the same one I just mentioned as 1. A equal to 1, 1 bar here is 0, 1 plus 0 here is 1. So whatever may be the input, see in this case whatever now in this case, whatever may be the input BC and BC dash complement, you always get 1 as the answer. So that what I'm going to mention here is, instead of BC plus BC bar, I just mention as 1. So what you're going to have here is DA. That means DA, it's nothing but it's an AND gate function. Hope you remember this one. A dot B, that is AND gate function y equal to. Similar here is, see, I just mentioned here, this is about AND gate as D symbol is there. See from this one, A, B and Y is equal to A dot B. Similar here, I just going to mention here this one. This is about AND gate function here. I just mention as, say this one is D and this one is A, and here Z equal to D dot A. So you are going to have AND gate. So answer in this case here is only one gate is required. That also AND gate. See about the next problem. This is quite interesting. So similar like this waveform of a problem, they will ask on what type of a gate that gives a output waveform, and whenever that gate is having this type of an input and this is getting an output, what type of a gate is this? With the help of waveform, we are going to find out what gate is this. And another one, all the previous year problem have highlighted over here. Now we'll go to the problem. Your logic gate circuit has a two input A and B, and output is Y. The voltage waveform, says they have mentioned here is voltage waveform as shown, and what type of logic gate is this. So we are going to find out what logic gate is this one. So first I just maximize here. So this one, instead of showing, I just draw all the waveform lines over here. First let me take the maximized form of this one. See, I have drawn here. See from this one, like this, similar all the points. See, first you consider about the A waveform. See here, this is 0 and 1. For the first line, if I mention this one, see for here, this is high input. See, always consider this is initial and this is final. You are going to find out the final one. Second wavelength, this one. See, this is initial and this is final. Third one is this is initial and final. You always consider about the final one. Let me draw the lines over here. Now, now let me draw the lines in all the cases. See, this one here is first one, second, third, fourth, five, and six lines. So what you're going to have here is six waveform. See, the first waveform of A wave, what is the input here is, see, I just mentioned here, input in this case, this is the initial and this is final. So that I just mentioned here, I will take the value of final one, that is 1. Here, second one is, final one is 0. And the third one here is, again, I just mentioned here, this is 1. Fourth one is ending point here 0. Fifth one is ending point here, that is 1. Sixth one ending point I just mentioned here, that is again 0. So this is about the first A waveform, and the second waveform I just mentioned the same. So here is 1, and here also this is 1. See, third line, the ending point here is 0, and the fourth one ending point here is 0. Fifth one again ending point is here, that is 1. Sixth one ending point is here, that is 0. Now next one, in case of Y waveform, I just take here. See, Y waveform, this is output here, this is 1, and here this is output, that is 0. Third one here is again 0. Fourth one I just mentioned here, this is also 0 here. Fifth one, this is ending point, so I just mentioned as this is 1. Sixth one here is 0. Now substitute in all the cases I just mentioned here. For this one, this is A waveform out input signal, B waveform input signal, and Y input signal. Now now I substitute here in all the cases. What is the input we got here? See this one. First one accordingly 1, 0, 1, again 0. Third line 1, fourth is 0. And B waveform I just mentioned here 1, 1, 0, 0, 1, 0. And output what we got here is 1, 0, 0, and a fourth line again 0, fifth one is 1, and sixth one is 0. See this one, this is typical to see, this is typically like an said, what are the gates over here? You just see about the gates. This is AND gate A dot B, OR gate A plus B, and NOR gate is A plus B whole bar. That means A bar dot B bar, and NAND gate here is A dot B whole bar. Now see what I'm going to take. This is similar to that AND gate truth table I just show you here. So this one here is A dot B, that is 0. So that means you just multiply here, 0.0 is 0, 0.1 is 0, 1.0 is 0, 1.1 is 1. Similar like this, 1.1 is 1, 0.1, 1.0 is 0, 0.0 is 0, 1.1 is 1, 0.0 is 0. So in this case, so this is equal to AND gate. Okay, next one again similar like this, again interesting problem here. So in this one, see, in the given circuit as shown in the two input waveform A and B, and both applied simultaneously to that gate in this gate, and what they are getting that output. So Y is equal to, with that output you have to form what is that output. From that you have to make a, what is that waveform from the output. See, for this, let me tell you here, the first one, see here input, what you are going to give the input here is, this is about A here, and this one what you are going to have here is B, and Y here is C. This one, this is OR gate, right? This is OR gate, and this two are this is NOT gate. I just mentioned here, this is NOT gate. Now for this one, first A is an input, what you are going to have output here is A bar. That A bar will be given to the input to the OR gate, and this one from here Y is equal to A bar plus B bar. Right. Okay. Now, first one. To understand this one better, I just take this diagram, zoomed off this diagram. Now, from here, now we have to going to create about the input in this case. See this one, similar concept. In the previous one we have seen. I just mentioned here. No, yeah. I just mentioned in this case. For the first one here is input here is, now it's going to start from here, right? Now ending point here is this one, ending point. So here is input, first one is 1, here is 0, second line I just mentioned here, this is 1, second input, third input, 4, and fifth input here. For the first input, second input I just mentioned here, third input again 1, fourth input again is 0, fifth input is again 1. Similar like this, B is going to start from here. Again I just mentioned here, input, this is about the ending point. Again I just mentioned here 1 now. second is 0, third one is again 0, fourth is again 1 year, fifth one is again 0 year. Now, see, you just make a truth table for this one. See here, I just mentioned in this case, truth table. Input here is A. Here is again, I just mentioned here. This one is B. And Y here is, see, this one already you got here. Y is equal to, what is that output here? A bar plus B bar. Now, this one I just mentioned here, 1, 0, 1, 0, 1. Here is 1, 0, 0, 1, 0. See in this one, see here I just mentioned here, y is equal to a bar plus b bar. 1 bar plus 1 bar, what you are going to have? 1 bar is 0, 1 bar is 0, 0 plus 0 here is 0. So I just mentioned here output in this case for the first one here is, see first one output y is equal to, I just mentioned as 0. Second one here is again 0 bar plus 0 bar. 0 bar is 1, 1 again 0 bar is 1, 1 plus 1 is 1 now. Similarly third one 1 bar plus 0 bar here. 1 bar is 0, 0 bar is 1. So 0 plus 1 here is 1. Third one here is again I just mentioned here 0 bar plus 1 bar. See from this one 0 bar here is 1, 1 bar here is 0, 1 plus 0 here is 1. Again this one here is 1 bar and this one here is 0 bar. Again answer here is 1. So what you are getting, that answer in this case 0, 1, 1, 1, 1. Okay now. So if the input in both the case, see I just mentioned here, in both the case, both input are 1, 1 in this case. See here, what is that output? That is 0. So that one I just mentioned here in this line. See for example, I just mentioned in this line. In all the case, I just extend here. So first one, here is both are 1. So output here is 0. Now next one, see this is 0 and this is 1, I just mentioned here. For example, to understand here, I just mentioned this one in a different colors so that you can understand here. See this one is 0, 1 and this one here is 0. See I just mentioned in this case. Now I just mentioned here. First one 1 and 1. So here is 0, I just mentioned here. Second case 0, 0. So here is 1. Am I right? Next one, next one is 1 0. Again here is 1. Next one is 0 1. Again it's 1. Last one is 1 0. Again it's 1. So that means now you are going to start from here. So here is ending point is here, and next one I just going to move. Second line ending point is topmost one. See here, and next one is here, here, and third one is here. So one thing here is how it's moving here. I just mentioned here. First one, see it's starting from 0 and this first line, second line is 1. So ending point here is this one, and third line is here, fourth line is here, and fifth line also here. So up to here, third, fourth, this one I just mentioned here. So from this one, what is that answer in this case? First option. Okay, next one. Next one is also one of the interesting solving problem. Identify the logic gate represented by the circuit shown in below. So these are all the circuit. From the circuit, we have to get what is that output. That output which is equivalent to any one of the gate. See for this one, first one, see here, OR gate, NAND and NOR gate, all this gate truth table formula, we know that one. See from this one, see here, this is about NAND gate. This is about NOR gate. Both output of NAND and NOR gate has been given to another NAND gate. That one you are going to get the final output which is similar to any one of this gate. See all these three gates assembled together, that will be equal to one gate. What is that gate that we are going to find out? See for this one, better understand to simplify this. First one, see here. First one here, what you are going to have here is, I just mentioned here, input here is A. See from this one you are going to have the input. From this one I just mentioned here, the input what you are going to have here is, that one here is B. Now see here, I just mentioned in this case, so this is A and this is B. This is NAND gate. NAND gate means AND gate plus NOT gate, that is A dot B whole bar. So what you are going to have here is this one, A bar dot will become plus and B bar. So this is one of the input. Similar like this is B, And see here, I just mentioned this one, this is A. So what you are going to have here is NOR gate is nothing but OR gate plus NOT gate. OR gate function here is A plus B. NOT gate function here is A plus B bar. That means A bar dot B bar. Right. This is again AND gate. AND gate C is equal to. So AND gate function here is one input here is A bar plus B bar. This is one input. That is A dot B whole bar. Right. Next one here is A bar dot B bar whole bar. Now this is about the C function. See, from this one I just mentioned here. See here, A bar plus B bar here, right? For this one function, one input, this one you just consider as one input to X. This one is considered as another input Y. So X bar dot Y bar. So what you are going to have here is X bar dot will become plus again here. So to understand this one I just mentioned here. Next one, A bar dot B bar to the whole bar. Now, see, you are going to expand this one. I just mentioned in different color. See here. So this one, say this one, even in this case also you are having whole bar here. See, you are going to substitute. See, in this case, just a minute. See, in this case, so these two are the input. So these two input, this is AND gate with NOT gate. So this is AND gate function is dot, NOT gate function is bar. So A bar, so A bar plus B bar to the whole bar, dot will become plus A bar dot B bar to the whole bar. Now you are going to expand similar like this. Now I just mentioned here. See this one, A bar again whole bar plus will become dot B bar to the whole bar. Now this is about one input function. Plus is not going to change because already we have changed. Again this one here, A bar whole bar plus B bar whole bar. Now again I just mentioned here. So this one A bar to the whole bar here is A dot B plus. So A bar to the whole bar here is A plus B bar to the whole bar here is B. So what you are going to have here is A B plus A plus B. Now this one, from this one common term I just take it over here. Yeah, I just take the common term B plus 1 plus B. So anything plus 1, what you are going to have here is 1 is the final answer. To understand this one already I told, you just put B equal to 0 or 1. Suppose I put B equal to 0, 0 see here, B equal to 0 or 1, you just substitute and find out answer here. Anything, whatever may be the input, you are going to have the final output here is C. See, in this case, whatever 0 or 1, you just substitute as 0. 0 plus 1 is 1 as the answer. And even 1 plus 1, 1 is the answer. So, whatever you are going to have, 1 plus anything here is 1 only answer. So, what I am going to mention in this case, now I just mentioned here. See, from this one, for final one here is A, B plus 1 here is again 1 plus B here. So, what you are going to have here is A plus B. That is, we call it as C equal to A plus B. That's nothing but this is function of OR gate. The next question here is, the circuit diagram shows here correspondent logic gate. See, for this circuit diagram, what type of logic gate in this one we are going to find out. See, for this one, see, there are two switches which has been mentioned as 0 0 or even 1 1, which means 0 means switch off, 1 means switch on. Similarly, like this, A and B switches also, if 0 and 1 is switch on, switch off, switch off and switch on. Okay, now for this one, let me tell you what are the inputs for in case of this circuit here is, I just mentioned here. See, this one, this is A and this one here is B. For this one, what are the input possible here is, there are four possibilities, as you know, this one 0 0 0 1 1 0 and 1 1. Next one, we are going to see about output, that is about LED. LED, that is why I just mentioned here. What are the outputs over here? See, for this one, to understand this one better here, I just tell you. See, first case 0 and 0. That means both the switches is off, both switches off, that is open one. So once if it is open means, according to this one, LED, that is light emitting diode. This is diode, remember this one, diode. In this case, if high potential is given to here, see this one, this is high potential, and here this side here is low potential. In case of LED, if it is forward bias, see from this one you can understand here, this is forward bias. So once if it is in forward bias, so what happen here is there will be a glow of light. See this one, see, remember this one, this is LED, light emitting diode. Diode, whenever if it is in a forward bias characteristics, LEDs glows. So that here what you are going to have here is light is on, so I just mentioned as 1. Okay, now next case, see here, second one is, this is switches open and this is switches closed, this is off and this is on. So this one 0 1. So whenever you are going to have this one here is, so light will be moving, see the current will be moving over here. See, before and all there is switches open in this case, so there is glow of light. So the first case there is glow of light, so in this way the current flow will be there. In the second case, see here, this is 0 and this is 1. Whenever it has been closed, see, compared to LED, this is like a short circuit, there is no flow of current. So that what happen here is, the current will be moving from here and it will be passing towards here, so there is no glow of light in this case. So that what I'm going to mention here is, here there is no glow of light, that is switch off condition, I just mentioned as 0. Similar in this case, see this one, next one in this case, see this one is, see here 1 0, this is closed, that is switch on, and here is switches off. So that here in this case the current will be moving towards this direction, so there is a bypass over here. So here is light is, so there is bypass, in this case there is no glow of light, so I just mentioned here also, that is 0. And next one, in the last case, both the switches are uh, on. That means here all the current will be, see, all the current will be moving towards this direction and this direction at the same time, both are parallel in connection, so current will be moving towards here. There is no flow of current across LED, so this one also I just mentioned as 0. So this is the concept. Now for this one, this is the answer what we got here. Now for this one, what are the gates they have given here is, see, OR gate, AND gate, NAND and NOR gate. See, this one you have to know about the truth table of this one, I just mentioned here. First one here is OR gate. OR gate here is A plus B, and next one here is AND gate. AND gate here is A dot B. Next one, NAND gate. NAND gate here is NAND, NAND gate. Simple, I just mentioned here, A dot B whole bar. And NOR gate. NOR gate here is A plus B whole bar. Similar one. According to this concept, see, A plus B already they have given the input. You can see there are two inputs. See this one, 0 0 0 1 1 0 1 1, that and all input you are going to substitute over here. So A plus B here is 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. Now this one, in this case, A dot B, 0 dot 0 is 0, 0 dot 1 is 0, 1 dot 0 is 0, 1 dot 1 is 1. Next one, in this case, you just take a complement of this value. So what you are going to have here is 1 1, again here also 1, here also 1, and this one is 0. And for this one, you are going to take a complement of OR gate. What you are going to have here is NOR gate. So 1 0, see here 0 and 0. For this one, you can understand here, see, NOR gate answer here is 1 triple 0 here, and this one LED here is 1 triple 0. So for that answer here, this case here is NOR gate. So this is university, this one, last previous year question paper they have asked this question. Okay, next one here is, which one of the following represents a forward bias? This is easiest question. See here, I just tell you. See this one, forward bias. Forward bias in this case, P type of semiconductor should be given a high potential, and N type of semiconductor should be given a low potential when compared to P type semiconductor. So this is called as forward bias. See, for that, I just let me mention here. See, in case of PN junction diode. So this is P type of semiconductor, and this one here is N type of semiconductor. I just mentioned here, this is positive and this is negative here. In a positive terminal, here is, in this case, if this is high potential, when compared to n type of semiconductor. This is low potential here. Hope you know this one. See, for this one, this is forward bias. So this is forward bias. If a negative terminal is given a high potential when compared to the p type of semiconductor, that is low potential, this is called as reverse bias. Now for this one, see, in this case, the first case, see, -4 -3, which is maximum value here is -3 is maximum value. So this is reverse bias. -2 +2. Here maximum value has been given +2. Here that is n type of semiconductor. This one also reverse bias. Here is 3 + 5. 5 is given to the n type of semiconductor. This one also reverse bias. This is 0. This is -1, -2, which is maximum value. 0 is maximum value. So this is forward bias. In this case, answer here is this one.